In this video, we're going to continue with our discussion of derivatives, and we want to talk about derivatives as a rate of change. So we actually may recall that f of x plus h minus f of x over h is an average rate of change of the function f over the interval x to x plus h. And then we defined our derivative to be the instantaneous rate of change of f, which was the limit as h goes to 0 of essentially that function. But specifically here, the instantaneous rate of change of f with respect to x at some given point x naught is the derivative f prime of x naught is equal to the limit as h goes to 0 of f of x naught plus h minus f of x naught, all divided by h. So that should all look very familiar to stuff that we've discussed already. But moreover then, if we start with a position function s of t here, well, our velocity function is the rate of change of a position function with respect to time. And that's exactly what this next thing says. If s of t is a position function, then the velocity function is v of t, which is the derivative of s of t, that position function, which, similar notation, we have ds dt here, or at least similar meaning, different notation, we have ds dt here. And what is the derivative of s of t? That is the limit as the change in t approaches 0 of the function s of t plus change of t minus s of t, all divided by the change in t, which just means the change in time there. That's pretty much exactly what we have up here, except we aren't plugging in a specific x naught. And we use change in time, so this change in t, instead of the variable x. But that both of those just mean some small change in your independent variable. That's all that means. And so what is that statement? Again, that statement is really that the derivative of a position function is a velocity function. So that's all you really need to get out of that, is that if we have a position function and you take the derivative, you get a velocity function. Moreover, the speed is the absolute value of the velocity function. So speed is the absolute value of v of t, which is the absolute value of ds dt, because again, this is the derivative of the position function with respect to time. Well, let's go ahead and talk about a few more things as well here. So our last definition for this video, we have acceleration is the derivative of the velocity function. So a of t is equal to v prime of t, which is s double prime of t. In other words, acceleration is the first derivative of the velocity function, or in other words, the acceleration is the second derivative of the position function. All right, let's do an example. So suppose an object is hurled straight up and the height in feet above the ground is given by the position function s of t equal to 160t minus 16t squared. How high does this object go? Well, what does that actually mean? Let's draw a picture real quick. If we have a picture here of that function, where our horizontal axis is our independent variable t, time, and our vertical axis is the height. Then here is our function, and how high does the object go? Well, the object reaches its maximum at the same time that we have a horizontal tangent line. Or in other words, when the derivative is 0, or whenever the velocity is 0. So that's exactly what we want to calculate. The velocity at some time t is equal to the first derivative of the position function is equal to, now let's take the derivative of this function. The derivative of 160t is 160. The derivative of negative 16t squared is negative 32t. We want to set that equal to 0 because we want to find out when they have a horizontal tangent line, i.e. the derivative or the velocity is 0. So we solve for t then, and we get t is 5. So we get t is 5, right? We can add 32t to the right. 160 is equal to 32t, divide by 32, and we see that t is 5. So then we just want to plug in t equals 5 into our original function, because that will tell us our height. So s of 5 is 160 times 5 minus 16 times 5 squared is 800 minus 400, which is 400. We're going to have some more questions here. So B is, what are the velocity and speed of the object when it is 256 feet above ground and there are 2 times when it is at that point, so on the way up and on the way down. So what do we have to do? We have to find out when the object is 256 feet above ground. Well, s of t was equal to 160t minus 16t squared. And we need to set that equal to 256. Or in other words, 16t squared minus 160t plus 256 is equal to 0. We can factor a 16 out of each of these to get t squared minus 10t plus 16 is equal to 0. Really, it's 16 times all of that, but since we're just trying to solve for the value of t that makes this true, we don't need to worry about that 16. This factors into t minus 8 times t minus 2 is equal to 0, or in other words, t equals 2, and t equals positive 8. So, if we look back at our quick sketch of the graph here, at t equals 2, we get somewhere around here, so the object, whatever the object was, is on the way up, and at t equals 8, the object is on the way down. So we want to find the velocity and the speed of the rock at that time. Well, again, what was the velocity? V of t, that was 160 minus 32t, and we want to find v of 2 for on the way up. So this is 160 minus 32 times 2. That is 160 minus 64, or in other words, 96 feet per second. And that is the velocity and the speed, because the speed is just the absolute value of that. So that is both the velocity and the speed. Then what about on the way down? Well, that is the velocity at V8. So this is 160 minus 32 times 8. 32 times 8 is 256. So that's 160 minus 256, which is equal to negative 96 feet per second. So the velocity at 8 seconds in is negative 96 feet per second. And so what is the speed? The speed is just the absolute value of negative 96, or in other words, positive 96. So we get that the speed is the same at both But at t equals 2, the object is going up, so it is a positive velocity. At t equals 8, the object is going down, so it is a negative velocity. All right, similar questions. What is the acceleration of the object at any point? Well, what does that mean? That means the second derivative. What is the acceleration of the object at any point? Well, that means the second derivative of our s of t, which means the first derivative of v of t. Well, what was v of t? V of t again was 160 minus 32t. So this is negative 32. So our acceleration at any point is negative 32. All right, and what about a last question here? When does the rock hit the ground? Sorry, not the rock, the object hit the ground. Well, the object hits the ground when the height is 0, right? So this is actually just going back and finding out when s of t is equal to 0, which is 160t minus 16t squared. Let's factor this. Well, we can factor out a 16t, and we get 10 minus t. So the object hits the ground at t equals 0, but really that's when the object was thrown or propelled upwards. And then it hits the ground at t equals 10. So at 10 seconds is when the object will hit the ground. All right, and that will conclude this video.